Okay, we will continue with the solving the problems based on LTI system. In the previous problem, here this in terms of a delta function it is given, but we here it's a different function here it is given. Just we go through here. Second problem, all the problems are important in the exam. Each question is asked in the exam. Okay. Here a problem it is given, that is a discrete time LTI system has impulse response h of n. Using linearity and time invariance property, determine the system output y of n if the input x of n is, x of n here it is given as u of n minus u of n minus 3, and our h of n signal it is given for us. This is also given, this is also given for us. Next, first we will draw the graph for the x of n signal. What is the x of n? It is given u of n minus u of n minus 3. What is our u of n signal? U of n signal from 0 to any infinity range. If I go for 1, 2, 3, 4, any values till it is going to be infinity with respect to time. It is all values are going to be 1 till it is infinity. Okay, this is our u of n function, right? Then next u of n minus 3. What is u of n minus 3? It is n minus n naught. N naught is the 3 value, n naught is plus 3. So our signal is going to shift towards the right side by 3 position. Here 0, 1, 2, 3, 4, 5, 6, it's going on. The samples exist, it is shifting from 3, 4, 5 and it's going on. This is our which signal? U of n minus 3 signal. Right? What we are going to do? We are subtracting these two signals. When subtracting means this is coming in the downside, right? At the 0th position only, here it is 0, here it is 1. For that reason, the resulted when I subtract these two, when I subtract u of n with the u of n minus 3, when I am subtracting here at 0th position, here it is 1, here it is 0, 1 minus 0, you will be getting as 1 only. For that reason, at 0th position, you will be getting as 1. At to 1 position, here it is 1, here it is 0. For that time 1 minus 0 is 1 only. So at 1 also you will be getting as 1. Then at 2, here it is 1, here it will be 0. So at 2 you will be getting as 1 minus 0 is of 1. Then when I come across 3, here it is 1, 1 minus 1 is 0, right? For that reason you will be getting as 0. Then at 4, here is also 1. For 4, here is also 1. 1 minus 1, sorry, amplitude 1 minus 1 is 0. For all the values, when I go from 3 to infinite value, it will be 0 only. For that reason, you will be getting the signal when I do the operation of u of n minus u of n minus 3, I will be getting as like this, samples. At 0, 1, 2 only you will be getting as the unit step function. This is our x of n. In the exam, they will not give the direct form of these samples. What you are getting, you have to do this. Okay. Then we got our, what is our x of n. Then we have to multiply our x of n with the h of n. When we have how to multiply, first we are going to take with the first sample. This is going to be multiplied here with the h of n signal. Okay. Observe here, first sample 0, at 0th position it is of 1. That part I am taken as x1 of n. Same as the previous, how we done, okay? x1 of n. h of n is going to be, it is taken as same as it is because it is not shifted, right? It is of x of at 0th position only. Okay, therefore same signal you have to write here. At -1 1, at 0 3, at 1 2, at 2 -1 3, it is 1. Okay, same thing you write here. Then I'm going for the next sample taken here, that is taken as x2 of n. x2 of n. What you have to do when I'm going for the next sample, our signal, what is h of n, it should be shifted by one position towards the, that's what here it is done. Instead at starting from -1, it is shifted by one position. So at 0 you'll be getting as 1, at 1 3, at 2 2, and at 3 -1 4, at 1. Okay, shifted by one position. Shift that and represent like that. That is our h of n signal. Then we are going for the third sample. Here it is of only third sample, go for third. If it is one more you get, go for one more step. Okay, then take that one more sample, that is of this. Then h of n is going to be, again it is going to shift it. You should not shift the original signal, you have to shift the shifted one. Okay, this is shifted, you will be getting like this. Again you have to shift this signal one more position towards the right side. Okay, instead of starting at 0th position, the sample, it will start at 1. At 1 it will be 1, at 2 it will be 3, and at 3 it will be 2, at 4 it will be -1, at 5 it will be 1. Next, what we have to do, we have to add the signal all. When I add all the signal, I will be getting my resultant, that is x of n is equals to x1 of n plus x2 of n plus x3 of n. This is x1 of n, add with x2 and x3, then I will be getting this x of n signal. That is what the resultant. In the same way, we have to add these three signals also. Okay, when I come across -1, first you write the scaling from -3 to 5 6 values. Okay, here it is, I know the limit, so I can write here as 5. If you don't know limit where it is going for, you can write 6 also. First you write the x-axis values to 6, and also in a negative side also 0 to -4 is enough. Okay, then at the -1 position, what is the value here? It is of 1 only. For that reason, -1, it's going to be 1. Then at 0, here it is of what? 3. Here it is of 1. Amplitude, in terms of amplitude, 3 plus 1 you'll be getting as 4. Then at 1 position, what is 1 here? It is 2. Here 1 is of 3. 2 plus 3 5, plus here 1 is there. What is total? It will be 6. Amplitude is going to be adding here. Then at 2, here it is of -1. At 2, here it is of 2. 2 minus 1, 1 you will get. 1 plus 3, what is you will be getting as 4. Then at 3, here it is 1. At 3, here it is of -1. 1 minus 1, 0. At 3, you will be getting as 2. Right? What you will be getting? 0 plus 2 plus 2 will get. Then across 4. Across 4 it is 0. Across 4 here it is of 1. 0 plus 1, 1. 1 minus 1. Here it is of -1 at 4th position. 1 minus 1, 0. For that reason, here it will be, you will be getting as 0. Then at the 5th position, here you don't have any signal, so any samples are not there. It will be 0 only. Then at 5, here also 0. Then I come for the last signal, that is at 5 it is 1. So we will be getting as here as 1 only. Okay, this is how you have to add the signal. Actually, in the this is what we are going to do. It is in terms of a graphical representation. Okay, in terms of samplings we are drawing and doing. these things we can do by using of the equation also. By using of the equation also. Okay, how it is done you will be learning in the next sem. Okay, just remember how we are going for this. Okay, this is how we are going to find the impulse response h of n by using of the based on the our basic samples, that is our step function, and also with representing to the delta function also. Okay, this is one problem. Then we are going for the next problem, that is evaluate the discrete time signal. Discrete time signal convolution sum given below, that is y of n, u of n convoluted, it's a star convolution, that is u of n minus 3. Okay, here we have to do what we have to do, we have to convolve one unit step with the another unit step. How it is going to be done? Okay, just you observe, this is very important, like these problems are very important, it will be asking directly for 6 marks. Okay, here what I am going to do, first I am going to consider the u of n as x1 of n is going to be u of n, then x2 of n is going taken as u of n minus 3. Then I will draw the signals for u of n and also for the u of n minus 3. I hope you can draw for u of n. U of n is unit step function, where it is from 0 to infinity, it will be 1 only. This is our x1 of n. Then u of n minus 3 means this u of n signal, it is shifted by 3 position towards the right side. That's what here it is drawn. It will start, the signals will start from 3 to the infinity. That is what our u of n minus 3 or else x2 of n. This first you have to draw this, then use the equation, that is y of n is going to be u of convolution with u of n minus 3, that I can write as x1 of n convoluted with x2 of n, because we consider that. Okay, for that reason. Next we are going to use the convolution equation. We already come across this equation, same thing I am using here. In the equation x of k, h of n minus k was taken, here in terms of x1 and x2 here. For that reason write the equation as y of n is equals to summation k is equals to minus infinity to plus infinity x1 of k into x2 of n minus k. You will be getting the equation. This is you have to write. You have to write the equation. Okay. Then first we will draw for the x1 of k. How to get this x1 of k? This x1 of n is there. If I replace n with the k, here it is written, x1 of k is obtained by replacing n by k. When I can get x1 of k, I am just replacing n with the k. So instead of x1 of n, it is going to be changing as x1 of k. In the time axis, here also instead of n, here it is going to be k only. Then the signal will remain as it is. Okay, same signal you draw here. Then in the same way, we want for x2 of n minus k. x2 of n minus k is obtained with equals to 0. Remember this condition, at n is equals to 0, we are representing the signal. That is, when n is going to be 0, what I will be getting here? When I substitute n as 0 means x2 of k, that is x2 of minus k I will get. How to get this signal? What we have to do? By taking a mirror image of the x2 of k. Means here x2 of n is this n by k and reflecting this. Yes, reflection if I do, I will be getting, instead of the positive values, it will be coming at the negative values. Here it is written. That is x2 of n minus k. It is going to be taken like this. Here it is in the positive. Take the reflection of that. Okay, you'll be getting like this signal. Then at the 0th position, when it is going to be 0, when n is going to be 0. N is 0 means k is equals to k minus n is equal to 0 means k is equals to n. Yes, based on this, at 0 you will be getting as k is equals to n. At minus 3, n minus 3. Just you go for the theory what it is written here. At k is equals to 0, consider it as k is equals to n. Okay, we have to consider at the 0th position as k is going to be equal to n. Okay, and last non-zero sample, this is non-zero sample. Here also 0 samples. Here it is of non-zero sample, that is x2 of n minus k with n is equals to 0. It's going to occur at k is equals to n minus 3. At n minus 3, you'll be getting the sample. That's what here it is going for. N is equal to 0 means k is going to be equals to minus 3. Right? Based on that. Then multiplying for the x1 of k for this signal and also for the x2 of n minus k, because based on this sample we have to check. Equation, not sample, here based on this equation. The summation must be carried out for the entire k axis, means for the whole minus infinity to plus infinity, the whole k axis we have to consider, where k is from minus infinity to plus infinity. Next, if n is positive, if n is integer, it corresponds to the forward shift of x2 of n minus k, and if n is negative integer, it corresponds to the backward shift. The same thing what we learnt in the shifting operation. Okay, of x2 of n minus k along the k axis. Okay, then we have to check for the first condition, where is our signal is going to be existing in the negative side. Okay, that we have to consider when n minus 3 is less than 0, means n is less than 3. When you going for solving like this part, when you are going for, just you consider the original equation, this equation, sorry, this graph, that is x1 of n, x2 of n. Okay, when n is less than 3, is there any signal for n less than 3? Here is also, it's not having any signal. For that reason, x1 of k, x2 of k, x2 of n minus k, it will be 0 only. Y of n is going to be equals to 0. Therefore, at n is less than 3, there is one condition. Then, when n minus 3 is greater than or equals to 0, that I can write as n greater than or equal to 3. Then the multiplication of x1 of k and x2 of n minus k yields non-zero value of, for when k is in between 0 to n minus 3. Substitute in the summation. Instead, it is varying from minus infinity to plus infinity. We have to change here as k is equal to 0 to n minus 3. How to decide this summation range? Just you go with the this first signal is from 0 to infinity is there, and next signal is from 3 to infinity is there, right? Means at k is equal to 0, you will be getting some signal, and at from 3, from third value, or else you can remember this point, k is from k at 0 and k at n minus 3. Okay, k is 0 to n minus 3. That is, equation is going to be taken as x1 of k, x2 of n minus k. Only here the limit is changing, remaining as it is, here it is written. What is the value? What is about x1 of k? Because it's of a unit step only, it is having only 1, 1, 1, 1, right? Here it is going to be 1 only. Then x2 of n minus k, here is also 1, 1, 1. Okay, 1. Then when I solve for this, summation n is equal to 0 to n minus 1. If it is of 1, you will be getting as capital N. Means if it is of n minus 1, you will be going for 1, it is going to be plus 1, it's going for. That result is going to be capital N only. Here also n minus 3 is there. It is going to be reduced by one more value, that is n minus 2 you will be getting. Compare here, okay, then you can write here. Therefore, you will be getting at n is greater than or equal to 3, you will be getting as n minus 2. Then we will be writing for y of n signal, that is going to be 0. Y of n is going to be 0 when n is less than 3, and it is going to be equal to n minus 2 when for the condition n is greater than or equals to 3. Only based on these two conditions. Okay. Next, in resultant, I can write here as y of n is going to be n minus 2 into u of n minus 3. Because our u of n will be from 0 to infinity, it will be 1 only. For that reason, instead of writing u of n minus 3 is from 3, it is going for n minus 3. For that reason, here it is written as u n minus 2 into u of n minus 3. Then multiplying for u of n minus 3 with this n minus 2 value. How to draw for this signal? First you substitute for n as 0. When n is 0 means minus 2 will be getting. So it's not, we don't have any signal to draw here. So we will be at u of n minus 3 signal at this signal. Okay. At this signal. Okay. Then substitute for greater values. Then 1, again minus 2, again. Then if I substitute at 3, okay, when n is 3 minus 2, 1 you will get. From third position we will be getting the sample. For that reason, start substituting for n is starting from 3 only. Okay, don't need for substituting for 0, 1. Okay, because our u of n minus 3 will start from third position. When I'm telling the x-axis means the position I am telling. Okay, at 3 minus 2 means you'll be getting as 1. When I substitute for next value, when n is 4, it is 4 minus 2, 2. Then 5 minus 2, 3. Then 6 minus 2, 4. Like this, it's going on increasing. This is our graph. You have to draw the graph and you have to write the resultant. This is very important. This is asked in the exam for 6 marks. Okay, this is one problem. Next, what we done, I just glance over this because somewhat it is lengthy, but it's simple. Okay, first, what is the given signal? What we have to do? First, you draw based on the given function. These are all the basic functions of the signal. Okay, first you draw those, then represent the first as x1 of n and second signal as x2 of n. Then use the convolution equation. Then replace the x1 of n in terms of k. Draw the signal. Then x2 of n at n is equals to 0 you have to take. Then you have to take the mirror image. You will be getting like this. Then you can write off this theory part or else you can leave off. Okay, no need of. First problem you have to consider how it is going to be done. Okay, then first we have to consider for the when n minus 3 is less than 0, means n is less than 3, it will be 0 only. Then n minus 3 greater than or equal to 3, use the equation, substitute for x1 of k and x2 of n minus k. You will be getting the result. The procedure remain same for all the problems. Okay, next we will go with the one more problem. Same steps, just you observe here how it is going to be considered. Here consider an input, that is x of n, and a unit impulse response h of n. It is given here. X of n is going to be alpha raised to n u of n, where our alpha is exists between 0 and 1. Then h of n is going to be u of n. Evaluate and plot the output of signal y of n. Okay. It is a given signal. Then what you have to take? Solution. What is given? I written here. Then y of n is going to be taken as x of n is going to be convolved with h of n. Yes, we have to do the convolution operation. Then y of n is going to be use the equation, that is k is varying from minus infinity to plus infinity, x of k h of n minus k. This is we know that this equation. Okay. Next, we have to draw for the alpha raised to n into u of n signal. This is alpha raised to n u of n. It is decaying function. Alpha raised to n is, for that reason, from 0, we don't know what is the value here. No need of thinking of that. Okay, now at a now point. Okay, we don't know alpha value, right? For that reason, they told that it will be from 0 to 1 only. Okay, it is exponentially decaying function. So you can at 0 1 2 3 4 5 6 going on, the value is going on decreasing. This is how you will be getting. Then h of n is of what? U of n function only. So you will be knowing, you just draw that it is always 1. Alpha is 1, so you can write here as the maximum amplitude, it will be getting as 1 only. Okay, here I wrote. Next, what you have to do? Replacing for n to k, so that I can get as x of k here. In the previous problem, we taken x1 of k. Here directly you can take, okay, x of k replacing n to k. So x of k is going to be alpha raised to, here n is there, instead of n it's going to be changing as k, then u of k. Here you have to write as k. I did a small mistake here. Okay, then what about h of n? This, what we have to do? We have to take the mirror image at n is equals to 0. So mirror image means positive values are going to be in the negative position. 0 to minus 1 minus 2 at the till minus infinity, the signal is going to be existing. This is also k. Then both the signals exist at 0 only. For that reason, what the condition we can go? When n is less than 0, or else when n is greater than or equal to 0. Then what is the convolution? X of k into h of n minus k. Both the signal, when you are going to do this, when I am multiplying x of k, here you will not get any signal, right? It will be 0 only. X of k into h of n minus k, it will be 0 when n is negative values. For the negative values, if you just observe here, for the negative values it will be 0 only. Then when n is greater than or equal to 0, x of k h of n minus k yields a non-zero value, that is k is exists from 0 to n. Then where it is going for? K is going to be 0 to n, means 0 to n. Observe which diagram I am referring here. 0 to n, for both the signal it is going to be existing for the k. So therefore y of n is going to be, k is going to be 0 to n, x of k h of n minus k. Instead of minus infinity to plus infinity, here the limit is going to change from 0 to n. Then what is x of k? X of k is going to be alpha raised to k only. Here u of k is always 1. Okay, for that reason alpha raised to k. Then h of n minus k, here all are having the 1 only, into 1. Then use the formula, alpha raised to 0 to n means 1 minus alpha raised to n plus 1 divided by 1 minus alpha. Based on the formula we are writing here. Therefore, at when it is going to be, we will be getting at when n is greater than or equal to 0. Therefore, y of n is going to be 1 minus alpha raised to n plus 1 divided by 1 minus alpha into u of n, u of n function. Okay. Next, what you have to do? We have to substitute for n values and also for the alpha values. Okay. You can check with this. Substitute for n also and also for the alpha value. Then you'll be getting the signal like this. It is increasing function 0. At 0 you'll be getting some values. Okay, you can substitute or else directly you can draw this graph. Y of n, if I take alpha as any of the value, whichever it's if you want you can go within the what range we have to take, within 0 to 1. If I take 1 minus 1, it will be 0. 1 by 0 means infinite range. If I take 0.5 or n for n value changing, it may be 0, 1, 2, 3. Like this you have to substitute. When you substitute this, you will be getting the signal like this. It is decreasing, increasing. At 0, it till infinity. When it is infinity, you will be getting as 1 divided by 1 minus alpha. Because when n is alpha raised to infinity means it will be 0. 1 divided by 1 minus alpha you will get, right? At the infinity, you will be getting as 1 divided by 1 minus alpha. Both the problems are important. This is also asked in the exam for 6 or 8 marks question. Okay. Okay, we will stop for only 2 problems. Next we will continue for the few more problems. Okay.